String theory is famous for its ability to count the degrees of freedom that give the entropy of supersymmetric black holes, but this counting is always done in a regime of parameters where the gravitational interactions are turned off. This leaves open the question of how these microscopic degrees of freedom look like in the regime of parameters where the classical black hole solution exists, and in my poster I discuss this question for the M2 M5P black hole, whose entropy comes from the fractionation of its M2 brane into strips stretching between parallel M5 branes, which then become independent momentum carriers. Contrary to the D on the 5P system, it is possible to track these microstates from weak to strong coupling by noting that the back reaction of these M2 strips ending on a single M5 brane is similar to the Kalman-Maldacena spikes describing FR strings ending on D3 branes. The difference is that the M5s and M2s extend along a common direction, and so instead of spikes, the M2 branes form furrows on the M5 brane world volume, and for multiple M5s and M2s, one gets a complicated maze-like structure of such momentum-carrying furrows that we call the supermaze. As a three-star system, globally, the supermaze preserves 4 supercharges, but an important observation is that if one zooms in on any piece along it, this number is enhanced to 16. Actually, it turns out that this local supersymmetry enhancement is shared by all non-microstate geometries, that is by all smooth horizontal solutions in supergravity that resemble a black hole from afar, but differ from it in the vicinity of the horizon. Based on this, we define a themelion to be any object in string theory that locally has 16 supersymmetries, but might have fewer when considered globally, and we conjecture that themelia should be the fundamental constituents of black hole microstructure. There are two main reasons for that, apart from the fact that all microstate geometries are based on themelia. Firstly, a themelion is necessarily a bound state, because one cannot separate its fundamental charges without breaking some of the 16 local supersymmetries. And secondly, a fully backreacted themelion can never give rise to a classical black hole with an event horizon. As for the supermaze, this is a themelion that should account for the entire black hole entropy, and therefore we want to build the supergravity solutions corresponding to it. This is an ambitious goal, but we have recently taken the first steps towards it. We showed that the supergravity solutions for 1/4 BPS intersecting systems of M25 branes are completely characterized by a single function that satisfies a non-linear Moser-like equation, and we demonstrated that given any momentumless M25 1/4 BPS solution, one can add momentum and appropriate fluxes to obtain a 1/8 BPS solution by solving a linear system of equations on the background. Explicit solutions are yet to be constructed, but as a first step towards building these solutions, one can look at the near brane limit of certain M25 intersections, where the BPS equations linearize, and one gets geometries of the form a S3 cross S3 cross another S3 warped over a Riemann surface. These are much easier to study, but the exact brane interpretation was unclear. To figure this out, we found a map between these solutions and the asymptotically flat ones we are trying to build, and showed that they describe single M25 intersections, which are however far from featureless. In particular, they describe what appears from infinity to be a single stack of semi-infinite M2 branes, ending on and deforming a single stack of M5 branes, but as one zooms into the intersection, the M2s and M5s resolve into physically separated spikes, with the distance between each spike being controlled by the number of M2s and M5s making it up. These are singular solutions, but there should be a geometric transition leading to non-singular ones, containing only bubbles and fluxes. Currently, we are investigating these solutions, and the next steps will be to add momentum to them, with the end goal of this endeavor being, of course, the supergravity formulation of the supermaze. If it turns out as we expect it will, this will finally constitute proof that the microstates of three-charged supersymmetric black holes are horizonless geometries.